Hey everybody, Steven here. So today I'm just gonna go over um, the exam of 2016 for the Architectural Technology 1 paper from Unitech. But in this video, I'm just gonna go over section A, so where they talk about the sizing the structural element, showing some details with the tightness questions and the bracing. So first, it's really important to carefully read what are the different elements. This will be useful later on when you're going to start drawing the details. But for the first questions, this is the important part. So I'm just going to switch to Photoshop. So it's just the same thing and with the plan next to it. Okay, so now let's go over the questions. So some of the things that you have to pay attention is the site context. So for example here, the building is located in an extra high wind zone. This is important. Refer to timber frame 3604. Usually they would provide you the tables that you will need to use to answer these questions. And SG8, I mean, it's important in general, but like during the exam, they will only give you the table for SG8 anyway. Okay, so let's go question A. Size of the veranda rafters. So what's important here is rafters and 600 centers and the fixing type. Okay, so let's go to the questions, the table. So I have it here. That's the table. And I'm just going to create another layer on top. So the rafters. So what we know earlier, they say it's 600 centers. So first rafter, and just going to put it in multiply, change the opacity to 60 so we can clearly see things. So it's rafters, 600 centers, and now we need to know the width and the depth of it. So first on our drawing, if you look here, so that's the section. The section is located here. How come we can't see that? I think it's because the drawing is on top. Maybe I'll just drag that drawing down here. Oops. And then go back here. So that's our section here. And what's important now is to find the rafter. So the rafter has this part here. It's the structural element that's supporting the roof. So now they're asking us, so rafter 600, and we need to know what's the span. So that's what we need to answer. So the span of the rafter is 2.9. So that's the distance between the ridge here to the veranda beam there. So that's the span. So that's the length that needs to be carried. The span is 2.9. So if we go down here, 2.5 is too low, 3.3. So that's the one we have to pick. And if we look at the sizing here, so it's 90 by 45. And I think we will ask also the fixing. So you look at the fixing on the other side. So it's E. So those are the two answers that we're looking for. 190 by 45 and E. And if we look at the bottom, that's the descriptions of the fixing that we need. So if we go back to a question, so we would need 190 by 45 and fixing E, and you can just write down what was there. So this part here. Okay, so that's the first question. We go back here. So now they ask us the what's important here is floor joist, 450 centers, and exterior space. This is crucial because if you look at the table they're going to provide, which is, oops, just going to delete that. Just turn that on and delete. So this is the floor joist. But then you get two tables, dry service, wet service. If you look at the floor plan, this is the interior, so usually this is where it's dry, and that's the veranda. And because it's exterior, there's chance for it to be wet. So that's the table that we have to look for. And they were saying 450 centers. And if we look at the floor joist, that's the thing that's located here under the veranda. And in plan, that would be something like that. Of course, horizontal. So the span, so if you look at the span here, this is 2.8. So we need to look something around here that's higher than 2.8. And this is 3.2. And if we go to the left, 190 by 45, so similar to our rafters. So that's the answer, 190 by 45. And so that's 190 by 45. So now they ask for 190 by 45. So now they ask for the roof, veranda roof edge beam, depth, and the beam to post fixing. And so they only asked for the depth because they actually already gave us the width. And so the post is here, and the veranda beam is this. So that's the one that's supporting the rafters. And it planned normally you would see it around there. So it's spanning from that wall here to that post there. So the span is 3.4, and that will be important when we go look at the table. So the table is 10.8 for the veranda beam. And let's just turn that layer back on. Veranda beam. So that's the span, 3.4. But one more thing that we need to find out is the loaded dimension. The loaded dimension is the load that the beam is carrying. So in that case, the veranda beam here is carrying that rafter there. So that beam is only carrying half of the load. So half of it is going to that beam, the other half is carried by that point here. So if we go 2.9, so we got 2.9 divided by 2, so it's going to give us 1.45. So that's our loaded dimension. And remember, this is 1.4, so it's smaller. So we need to get 1.8. So that's where we have to look at. And I think from the description, we had a light roof, like a metal roof. So this is this one that we have to look at. And the span, like I was saying, this is around the beam is spanning from here to here. So it's 2.4. And so we have to come from here and go down until we reach 2.4. 3.4. So it's this, there's 3.4 here. So normally you would go to that point. But because they told you that it's a 90 like the what's it? I think they say width, but it needs to be 90. So just keep going down. So 3.4 here, and then you go all the way here. So the depth of the veranda beam is going to be 240. So if you look, so that's the veranda beam. If I were to make a drawing, that'll be like that. Usually it will come in two. So this is 240, and this one is 90. So usually they would just sandwich, well, put two 240 by 45 together, because usually that's a size that's more common, rather than having one big piece. But you could just draw it one as well if you wanted to. And they also ask the fixing. So the fixing is going to be, this one is going to be P, and it's here. It's this one. So you have to go through, I think this is, where is it? You have to go back to 3604. Oops, I'm just going to bring it that here. So 3604, it says figure 9.3. And let's go to the mark. Figure 9.3. And that's it. It's drawing B. So that's the type of fencing that you would need to provide. M12 bolts. So the straps as this one, that's the middle thing, and then you get bolts on it, and that's the beam and the post here. Okay, so now we got that. Just gonna delete and go back here. For our answer, we had 240 by 90, and the fixing was P. But I think you'll need to details like the stuff that I showed you in 3604. So now they ask us about the size of the door lintel. Go back here. So the door lintel, D1. So that's the only door that's here. And so that the door is here. So that's D1. And that's the lintel here. So it's to carry the load of the roof that's here above it. And the span, like it's written here, it's 1.6. So that's like the width of the door. And now we're just gonna go to the table of the lintel. So it's 8.9, and all wind zone, you don't have to worry about that. And SG8. All wind zone, SG8. And so we know it's a light roof because it's a metal roofing. The span is 1.6. Oh, we need to calculate the loaded dimension. So like we did earlier, we need to find out what's the load that this wall is carrying. So you have to imagine this is carrying the weight of this side as well, but it's only carrying half of it, because let's say the weight of this structure is half of it is carried by the veranda beam that we calculated earlier, and on this side half of it is carried by that wall here. So the loaded dimension, that's on that lintel is only this. So what we would do is, so I know this is 6 meters. So if I take half, so this is going to be 3,000. And then half of that is going to be about 1.5. And okay, it's a bit weird that this is 2.8. But never mind. So normally 2.8, so that's the span between that wall and that post. So half of it is going to be 1.4. So 1,400. This is 1.5. So if you were to calculate, so it's going to be 2.9. And so that would be my loaded dimension, 2.9. So if we look at here, 2 is too small, so I'm just going to go with 3. And then my span is 1.6. So I have to go all the way to here. So it's 1.7. And then my lintel size is going to be 140 by 70. So that's how you do it. Make sure you calculate the loaded dimensions. Remember, it's always half of each sides. Okay. So usually, like the roof structure is either supported by like lintels, beams, or walls. Okay. So now we got the answer. 140 by 70. I mean, here, because this is the lintel, that the wall, normally the span will be the things in between, but because right here they haven't really give you the width of the wall, so you can't really be that accurate, but I mean, roughly it was 2.9 loaded dimension. Okay, I think the next questions are this exam. Construction detail. So window jamb, eave detail, corner detail. It's really important to go back to question 1 and kind of read all of this. So let's go back to Photoshop and just going to delete that. So what's important when you do the detail would be the cladding, the interior lining, the architrave, the roofing, so it's corrugated zinc aluminum, spouting, so there's like this thing here that's receiving the water, the soffit lining, so that's usually the thing here that's kind of hiding the rafters. All joinery anodized aluminium, so joinery is like the windows, doors, concrete floor, and this is hardwood decking, excavation 16. So the details they ask, window jamb, if detail, corner detail. I think if this one you just have to practice drawings of detail, and I think if you look at your lectures, like this one from quarter 4 and then here you get some drawings. Think about the shape, the dimensions. But what I would recommend is to always start with the framings. So do the big part first and think of it as a layering process. Let's go into Photoshop. Into details. So for example, I think the first one they ask is the windows. So there's some with cavity and some with direct fix. I'm just gonna slide this over so you can see what's the difference. But yeah, so they were asking window jam. So jam, that's like in the middle. So I would personally start with drawing the framing. So you would draw this one first. So that's like the studs. Usually the studs would have a cross because it's a member that's going from bottom to top. You have like the smaller ones here. That's like a nogs, or like you can see here. That's kind of like, let's say I was doing an elevation of that wall. So this is the studs, and then that's like the section cutting and looking down, and then you would have like little small members there. So those are those ones, or like it would be cutting, but it's an element that's not going all the way down. Let's just delete that. So I would start with this, the framing, and then I would draw the line there. That's like representing the bottom plate, the things that you'd see at the bottom. And then now I will start to layer the different elements. So here you can see there's the wall underlay. So this one usually it's like dotted line, and it's gonna wrap inside. And usually on top of that you would have like a flashing tape. The flashing tape will also go all the way there. Make sure that you use a different line type. So maybe instead of having dash, maybe you could have a longer dash, a point, or dash, or maybe just points. Really up to you, but you have to come up with a line type that's different so people can see its different elements. In some cases, you might not use any wall underlay. You might use a rigid air barrier. So you just have to do the true line and just label it as such. Then here you get the interior lining. I think that's what we had earlier. And then here you get some packers. And another one. I think the air seal is important to have. And then you get part of the framing. Yeah. If you want, you can add some texture to really take your drawing a bit to the next level and to kind of help differentiate the different element. So here it's just like renders or little dots, and here you can have like wavy stuff to create the textures of the wood. And then I will start to add the cladding. So this one is a beaverback weatherboard. And then after that you can start to draw in an idea of the profile of the window. In this case, because they say it was aluminum, I think in the question. Aluminum. So that's the type of profile. And make sure external wall cladding, underlay, internal lining, finish insulation. Yeah, so here normally what they didn't add is the installation. I think it's that type of graphic that you put in here. And then you have to remember this is the head flashing over, so that's good to add as well. But yeah, I mean, you just have to practice to draw. Um, so that's kind of what it would look like. And what I would recommend is to kind of do like a light draft on your paper first, because you have to think about um, writing each element, like the labels, and try to get everything lined up. It just be more clean. So that's the jam SLE that we just drew. Um, if you want, you can add that here. That's like a line break. And yeah. So when you add the label, write the name of the element. If you know the sizing or the material, add it there as well. Some spacing here be useful information as well, like the critical information. What else? It's about the same thing. It's not a drawing. Try to keep everything lined up on one side. Put the sizing of the different elements. And here you see put the installations. They put some renders like the little dots to show that this is the interior lining. There's a ceiling lining here at the top. And they even, so that's the rafters, the soffit lining. And yeah, I mean, you can never know what you're gonna get for the exam, which detail they're gonna ask you. But I think from past exam is usually openings, maybe roof eaves, and the bottom of the cladding where the what is the main image? So usually, oops, delete. So like in this one, they asked you to do the roof eave. I think knowing the everything about the window is important. Um, I think like the wall base connections is also important. So this one is there's a concrete, and this one there's like the veranda and the like the timber decking touching here. Mm, yeah, I think I would really pay attention to those like around the wall. I don't think I ever had stuff about the roof there. But I guess you never know. In this case, they ask you the corner detail, and so if you were to look at this, so those are the corner details. I think on the corner, what's important is not forgetting the flashing. Yeah. So you have your framing there, the flashing, and then the wall underlay. You always have to remember that on the framing there needs to be a layer of protection, either wall underlay or rigid air barrier. Then you have flashings, and then you get the cladding. Okay, let's just move on. What are the next questions? And usually, if they say 8 marks, I guess you need to add 8 stuff in your drawing. So you would get like a 1 point for each element, and I think maybe you get some points for how tidy your drawing is. Okay, weather tightness. the four major principles. So all those questions, I think you get it from your lectures. So the four Ds are what drainage, deflection, durability, drainage, deflection. Fourth one, I think is it dry? Oh, oh yeah, drying. So deflection, drainage, drying, and durable. And yeah, just have to remember all this. Explain how metal flashing are used in relation to water. I think this is in your lecture as well. I think the flashing is about drainage. So it's here. And then I think you need to draw that diagram where you show the framing, and then you get the wool underlay, and then you get your flashing, another layer of wool underlay, and the cladding, so that if any water goes behind that cladding, it will go on top of the wool underlay, reach the flashing, and be ejected outside. Draw three profile in sections of cedar weatherboards. Clearly name each profile. Because for that, cedar weatherboards is a cedar is timber. So I went and looked at this website. I mean, there's different profile, but there's three type here. It's rusticated, bevelback, and vertical shiplap. So let's go click on that and see what they look like. So that's what a profile of the rusticated weather will look like. If you go into CAD drawing, you would see that in plan, that's how they would be installed. Actually, that's not in plan. That's so that's horizontal weatherboard. So that's kind of like more like a section. Because if you, as you can see here, that's the section. So that's kind of what you would have to draw. So like the framing, the cavity, and the profile. I guess what you have to remember on this one is that it's at the back it's kind of straight. You still have some the gaps here, and then the front it's like curvy and then flat, and they actually overlap here. I guess that's what you have to remember for rusticated. And now we go to bevelback, and usually that's a horizontal cladding as well. It's kind of what it looked like. Go to the section, so you get your framing, internal lining, a cavity, and then you get the weatherboard. So this one I usually angle. One side of it is flat, so it's you can rest it against the cavity pattern, and then angle, and that's where they join. And yep, so that's what you'll have to draw. That's the profile, and that's some 3D view of the cladding. And the last one would be the vertical shiplap. So it's kind of similar like the rusticated, but I guess it's just vertical now. And so those are like the profiles. So I guess here you just don't have that curve, because they need to overlap uh, alongside each other, like you see in that drawing. So just leave that little gap there. So those are three of them. So what's the minimum durability requirement for exterior cladding? This answer you find it in E2. E2. I think this not was. Oh no, this one was not E2. There was B2AS1. B2AS1 is the durability document. And then we want page 17. So if you got durability requirement by building elements, so cladding, because this is exterior, it's non-structural, go here, and that's 15 years, so that's the minimum. Go back here. In which zone must a rigid air barrier always be used, and list to advantage? So this one can be found in one of the lecture that was done by James Hardy. So rub board needs to be used in extra high wind zone, and some of the advantage of having this, it can act as a temporary weather protection during constructions. So you can install it directly, and then you can work on the outside, inside. Used for bracing, and can have some fire rating as well. So those are like three advantage of having a wrap board. In what situation would the wands bar be used? So this one, it's in E2, ES1. So this is where they talk about the wands bar. It's called like a sill support bar. And if you look at the drawing, it's that here. And it's usually used when you have a cavity. So if you use bevel back on cavity, the window would be offset from the frame. So you would add a sill support bar at the bottom to carry the load of that window. So that's what you would have at one bar. Okay, so now we're gonna go to the bracing. Let's go back into Photoshop. Turn that off. And bracing. I need to show that drawing again. Excuse me. Okay. So we knew the cladding, interlining. Those are not really important for the bracing. Okay, so all bracing for the building to provided by interior wall panel, no less than 1.2 long, so that's important. The bracing element EP1 have a rating of 120 BU. Extra high. The bracing line NNABC shown on the plan. So if you look at the plan here, you can see M, N, A, B, and C. So usually the bracing line for M be like this. N and A will be in that direction. So usually you want them a bit spread out, at least every 6 meters. So that's what's done here, 6 meters. And so now find the wind bracing demand, wind W across, W along, and use that table. Okay, turn that off. And where is the bracing table? I'm gonna turn the question off. So that's the bracing table. And I'm just going to create a little on top so I can draw. Multiply 60. Okay, so when we have that table, there's two information that we need to get. The single upper level to the apex, so it's H, so that's like the height of the building, and the roof height above the eave, so mini H. So normally in your sections, you would have those labels here. So you can see this is the floor level to the apex, and you get that little H label. So it's 4 meter, 0.1, and the roof height above the eaves, that's 1.1. So you can see that little H here. Really pay close attention. That's like clues of the information that you need to look at. So if we look at here, we got 4.1, so we need to get something that's above 4.1, so it's going to be 5. And the roof above the eave is 1.1, so 1, no, too small, so it's going to be 2. And if we look across here, so those are the values that we have to look at, 50 and 55. It's going to be 50 across and 55 along. Okay, here what you have to be careful is of the wind zone. So that table is only for high wind zone, and depending on where you are, you have to multiply it to there's a multiplicate figure, and so in the question it did say extra high. So extra high, you need to multiply by 1.6. So those values here, so the wind across is going to be 50 times 1.6, and the wind along is going to be 55 by 1.6. If we use the calculators, 50 by 1.6, so we get 80. So this is going to be 80 here, 80, and we get 55 by 1.6, and this one we got 88. So those are the values that we have to look for. Where are the questions? Not this one. Okay. And we're gonna go back here. So we had wind across. It was 80, and along there was 88. So now we have to calculate the wind load. So you take the values that we have and multiply, and we have to multiply by the length and the width of the building. So here you can see wind across. So wind load across is this multiplied by the length. So the length of the building here is this 7.2. So this one would be 80 times 7.2. So you're gonna get 576. 576. So that's what we need to get at least the minimum. And the wind along is 88. Multiplied by the width. So the width of the building is 6 meters. Yeah, make sure it's multiplied by 6, huh? Everything is in meter. 88 by 6. So it's 528 along. Okay. So now we get 2 marks for that. And locate and label the bracing element showing on the plan and the schedule. Include this spreadsheet in your answer book. Okay. I'm just going to change color. Maybe I'll take a blue. Okay, now we have to start with bracing across here. So we know that all the bracing have a value of 120. And because we're only using one type, we know that everything here it's going to be 120. And even here, because we're only using EP1. Okay, now we go on bracing A. And if you look at here, it says all the interior wall panel that will be used for bracing needs to be at least 1.2 long. So if you look on the bracing line A, the only place where we can have that at least 1.2 is here. So you would put a bracing here, because of course it's 1 meter too small. So that bracing element will be called A1. Usually if you had another brace here, you would call it A2, but in this case become only A1. So bracing element A1, length of the element 1.8, make sure, because it's in meters. On the drawing it's in I think it's in meters, but they just added all the zeros at the back. And then here you would do the multiplication. So 1.8 multiplied by 120, so you get 216. And then now you go to B. Well, the only place you can have a bracing is that wall here, and that wall has a span of 2.8, so that'll be 2.8, and that would be B1. I would put B1 there, 2.8, and 2.8 multiplied by 120, you get 336, 36. And C, well, the only place to have your bracing, it's going to be here, and that's going to be C1, and that's 1.2. C1 and 1.2. Calculators, 1.2, so 144. And now we just have to add everything together. 144 plus 336 plus 216. So we get 696. 696, and because it's over 576, so it's all good. So now we go for bracing along. So it's in that direction. I'm just going to change color to make it clearer. Let's go with some type of pink. M. So M. So it's along this wall here. So the only place we can have it is here. Maybe I'll pick another color. This color. It's gonna be this one here. So this one's gonna be called M1, and it's 1.5. So we're gonna go here, M1, 1.5, and then we calculate 120 multiplied by 1.5. We got 180. Then we go to N here. So the only place where we can have it is here, 3 meters. And it's going to be N1. Usually, I think when they do those kind of drawing, they would put the dimension where it's relevant. So like, for example, here, this could have been 1.2. But actually, no, like this is 1.2. You can clearly see this is a bit smaller. But usually they will put the dimension where it's relevant. So this is going to be N1, and it's going to be 3 meters. Do calculation. 3 meters by 1.2, by 120. So we get 360. And 120. Yeah, correct. Was it right? 1.5. Yeah. So 120 plus 360, got 540. So we just over, but that's enough. So yeah, locate, label, and calculate. So maybe you can yeah, don't forget to put some of the label here. And yeah, I guess that's it, huh? That's it for section A. Oh well. Thank you. If you have any questions, just put it in the comments. Or yep. Thank you. See you guys.